Thank you very much for that introduction, and thank you very much for the organizers for inviting me here in this graphene city, and it's my first time here, so I really enjoyed looking at the facilities, and it's really impressive, and look forward to the round tour today as well. I'm here to talk a little bit about this topic in the perspective of a large industrial company, an end user maybe, or the second last step to end use of graphene products, and also about our journey towards putting graphene-based products on the market for electrical switching, and in particular metal graphene composites for enabling maintenance-free circuit breakers, which was a work conducted in a so-called spearhead project within the Graphene flagship in collaboration with, among other partners, University of Manchester. So I will come back to that in a few minutes. But first, for those who don't know anything about ABB, I just briefly want to share that we are a big global company, more than 100,000 employees, active in the fields of electrification, motion, process automation, and robotics. And these sort of scattered areas are loosely held together by our ambition to provide digitalization and electrification solutions for the digital and energy transformation that is currently ongoing in the world. More specifically, we are organized in 4 fully decentralized business units. Business areas: electrification, motion, process automation, and robotics, as I mentioned. And within these we have 19 sort of separate divisions working as separate companies within the companies, and targeting different aspects of these areas. Our endeavors, our activities within the graphene area are nowadays focused within 3 of these divisions: distribution solution, smart power, and low voltage motors. And they are all focused on developing or utilizing graphene composites for tribological applications in electrical contacts, electrical switching, and also mechanical mechanisms. So this is just a small part of what graphene can do, but I think a lot of these divisions have an interest in potential graphene solutions, and I think it's just a matter of resources to sort of probe the other opportunities. But we as scientists within the Corporate Research Center, we always have a little bit of hurdles getting into these companies. It's a big company, and you have to get to know people, and it's not so easy to talk to. But now we are on our way to sort of conquer this area. I think in particular sensor technologies, measurement and analytics are of interest for graphene-related products. Thermal management also covers a lot of these. But I should also say that nowadays, as you've heard in many talks, both yesterday and today, sustainability and our net zero ambitions going forward are sort of integrated in all the activities that we do currently. And in regards to product development and R&D, I've just circled these green parts. All the activities need to aim at these targets that we have set up for the company, to support our customers to reduce CO2 emissions, and that all our products should be in a circularity or have a circularity approach and be recyclable and so on. So, with that in the background, when it comes to graphene, we started quite early, like in 2015 or something. We heard about this fantastic material with so many interesting properties. And we actually sat down to talk about what opportunities there are within ABB. And we came to the conclusion at that time that nanocomposites were something, someone said yesterday was a low-hanging fruit, and we also thought it was a low-hanging fruit, kind of modifying existing material and utilizing the multifunctionality of graphene to enhance our products. And in particular, we thought that we could enhance the durability and longevity and the lifetime prospects of many of our products, especially in the switching area, with graphene, knowing that it has excellent tribological properties, excellent electrical properties, excellent thermal properties, and corrosion properties. That, of course, went hand in hand with also the sustainability goals that we had set up, and also the European and global targets that are ever present nowadays. But I think what really interested us, also because we had the competence within this field before, was that graphene could work as a dry lubricant. This is not covered in so many projects as I would have wished, but we are very interested in this area, and the reason is, of course, that graphene has these very beneficial properties. One particular property that we were interested in was a study by some US researchers showing that graphene have less, compared to graphite, graphene is less sensitive to external environmental conditions, so it could act in both humid and dry environment. And this is particularly interesting for electrical switching devices, which are placed in various locations throughout the world, in dry deserts and in offshore wind plants and so on. So I think this was one of the reasons why we wanted to explore the dry lubricant properties of graphene, and eventually maybe to be able to replace standard lubrication as grease and oil that has been around for 100 years and never been changed and so on. So this is an area where we saw a lot of potential, because it's also used in many of our products. This has been quite a long journey, and it has not been, would not have been able to do without external collaboration. And we started already back in 2015 with some national funding from the Swedish graphene funding organization, SIO Graphene, with creating some know-how and basic processing technology of making metal graphene composites, which we were interested in pursuing. In that period, we were working on silver graphene composites, actually. Then we have transitioned through various bridging projects, also nationally funded, but then, and also managed to produce one product, but that was sort of, that part of ABB was sold in 2019, so we are not working on that project anymore. But eventually we transitioned into Graphene Flagship Core 2, where we got the possibility to access a much larger partner source or collaboration source with startups that had developed technologies that could be of use for our applications. So then we had a project on silver graphene coatings for electrical switching, but when the graphene flagship transitioned to Core 3, we actually had a spin-out project proposal for one of the spearhead projects that we're running, utilizing this technology but applying it to completely mechanical drive, just a mechanical drive system, no electrical current going through the system. Because this was a request from one of our divisions to, can we replace the lubricating grease in our drive systems with graphene? So then we actually got this spearhead project approved, and this was a collaboration with University of Manchester, as I mentioned, but also 4 other partners, among which 2 are SMEs and then institutes and universities. And I'll tell you a little bit more about this project. The main business case selected for this project was air circuit breaker, low voltage air circuit breakers. And these products are switching devices in the low voltage grid, a volume product. They are placed everywhere to protect critical grid assets in case there is a grid fault or failure. And the opening and closing operation of these devices has to happen very quickly, and it's governed by a mechanical drive system that is grease lubricated, and it cannot fail because then it could have very catastrophic consequences for data centers and so on. But the thing is that the mechanical drive system, which is grease lubricated, the grease has issues. It ages and it becomes thick and viscous, and the operation can slow down and even stop to function. And therefore, all of these circuit breakers are sold with a service program connected to it. So every year or every other year, there is a service guy who comes and takes everything down and puts everything apart, cleans the circuit breaker, re-greases, and puts everything together. And that takes about 8 hours. So it's a massive amount of work and money that goes into the service organization, and also driving to these sometimes remote locations and so on. So removing this, solving this problem, removing the grease would enable to significantly improve the robustness of these products, but also the sustainability over the complete lifetime. And even though this service program is ongoing, the number one cause of failure is still lack of lubrication in these devices, and that was a big problem for our business units. So the goal of this spearhead was pretty clear. We wanted to produce the first of its kind maintenance-free circuit breaker by replacing the grease lubrication in the mechanical drive system, which consists of various joints and release mechanisms, and doing so by applying a metal graphene coating on component parts, or completely replace parts with a metal graphene composite, a sintered graphene composite. And the benefits would be a cost-efficient and sustainable solution, and with no service organization requirement, and stable and worry-free operation regardless of use and environment that the product was based in. And the deliverables that we were supposed to deliver was a material concept, either coating or a bulk solution, or both, a large volume manufacturing process, and a grease-free, maintenance-free circuit breaker prototype in the end. And I can say already now that we actually managed to do so. And we started off with materials optimization, developed a multi-layer solution containing a copper graphene functional layer, and then with some additional coatings that had really good tribological and wear properties, low friction, low wear, and also excellent corrosion properties. We managed to scale up the process, which was based on electroplating, which is a cost-efficient and scalable process, and our partner Nanisa, in collaboration with a large-scale commercial electroplater, managed to scale the process in up to 300-liter baths, I think. Managed to coat very complex components, shapes, and validate the consistency throughout these large baths, and also over time that the bath properties were consistent over a long time. We at ABB followed up this by testing the component, or the coating and the component in what we call the actuator demonstrators, parts of the mechanical drive system where we could show the benefits of the coating in a real product environment. Measured release forces, and also with and without aging, before and after, and so on, in all different various combinations. And in the end, we performed these product tests, standardized type tests according to regular, standards, product standards, and we passed all the tests. So this product is actually validated for use in these products now. And they included electrical, mechanical endurance, vibration, aging, and so on. So we were very happy about that. And that was carried out like 1 week before the project ended, so it was just in time. And by doing so, we have gone from TRL3. We had some already done some work on the coating technology, and then in the end we are at TRL6. And now we have a commitment from our business unit. We have handed over the results to our business units, who are carrying out the continuation of the productification. I don't know, 4 minutes, great. So I just wanted to finish off with just highlighting the fact that we at ABB, even though we are a big company, we can't do this on our own. I think the collaboration and the putting together a nice consortium of excellent partners has been the key to success. We have the SMEs that have developed the key technologies that we could benefit from. They were also connected to large-scale manufacturers. We had excellent support from the universities and institutes in regards to characterization and also modification of the GRMs. Here, University of Manchester, I have to highlight University of Manchester and Nikki, who are there, who really put a big effort into understanding the mechanism, why this system worked so well in our products. And this has really been useful for us in planning ahead of what's the next step.
And we finished off our collaboration with the interest in the Graphene Week, where we showed a demonstrated one is with these mechanisms
that we demonstrated. My colleague Sue presented the mechanistic work that was carried out by University of Manchester, and I presented the product output, and then we had some posters. And I should also highlight that we went to visit our factory in Sace in Italy last year, where all the people were present, most of them. I think the University of Manchester guys here, Mark was also there. They had already left for the for the plane when the picture was taken. And then my final slide is just to summarize that we at ABB see a very big potential of using GRM materials for tribological applications, low friction, low wear, and also in combination with the electrical and corrosion resistive materials, and for replacing grease. And we think that scalability of the processing is a key, and also putting into prototypes is very, very important to identify the critical issues. And as we are working on sort of volume products and generic problems, we think that this technology or these solutions can be transferred into new applications in the next step. So with this, I finalize and conclude. Thank you.
Thank you very much, Anna. Excellent insight into collaboration and engineering system design. I mean, it's a well thought out and well put together program. Congratulations, by the way. But any questions to Anna, please?
Hi, does it show any limitations in large LV switchgear, such as RCI equipment or generators, anything like that? Have you reached into that sort of isolation switches for generators, large LV gear?
Yes, I mean, this is what we are discussing now. We were working on this circuit breaker as a system case or like a model system, but we see a lot of opportunities also in other areas.
Okay, and will that be for ABB equipment only, or is it something you'll produce as a standalone market product to other manufacturers?
Well, for now it's ABB products, but I think also going forward it's a matter of now we are working together with energise, a graphene company in Italy, and of course they want to expand. I mean, it's a matter of IP and how we handle it, and how they also can they of course don't want only ABB to be their customers, but expand in other areas.
Sorry, one more question if I could. Do you know its switching capabilities versus standard isolators? Is it faster? Is it comparable? Is it slightly slower? Do you know if it is the same?
In our release, I mean, we measured the release force and the release time, and it was actually better than the graphene or the grease lubricated. It was more stable. We were further from the limit. Current solutions are at the limit actually because they are designed to be, but we are so we believe that we can reach longer lifetime.
And is it in your products at the moment? Is it available? Or
no, I think what I also wanted to say that is these big companies are very slow.
They are.
So it's slow to get moving, and now we have the snowball rolling, so to say, but it's still a process to get into a new product, and that has to follow some procedures, and there are priorities also on the
There'll be there's obviously plenty of opportunities to catch up on the more technical side. Yeah. Any more questions quickly for Anna before she finishes? One more for.
Curious to know if you have already identified a single source of graphene, or you're working collaboratively with different suppliers to make sure the material is reliable.
So far we are working with one supplier.
But as products develop, others will become available.
The next step is the supply chain topics
Exactly.
in relation to the product development.
Okay, Anna, thanks very much. Very informative talk. Thank you.